morning, dear friends. In the last video, we discussed about the fundamental concepts of refraction of light. In this lecture, you will come to know about the incident ray and emergent ray. You might have observed in the ray diagram of last lesson that these two rays are parallel to each other. I hope you have gone through the things at the best and might have understood the concepts of refraction. In this video, you will see why these two incident ray and emergent rays are parallel to each other. So let us begin with the lesson 2.
So, dear students, in the last video about refraction of light, we understood the fundamental concepts of refraction of light. The last result of that lecture was about refractive index, and that is mu2 1 is equal to mu12, where mu2 1 is refractive index of second medium with respect to first medium, and mu12 is refractive index of first medium with respect to second medium. One more thing we discussed in the last lecture that is very important, and that was emergent ray is always parallel to incident ray. Today we will show that why it is necessary these two rays are parallel to each other. To understand that, I redraw the ray diagram again, which we had taken on that day in that lecture. This is incident ray. This is angle of incidence. This is refracted ray with angle of refraction theta r. On the opposite interface, this is the emergent ray. This is glass slab ABCD. We had taken this angle as angle I and this angle as angle R. These are the two parallel rays. This one is refracted ray, and this one is emergent ray. So now we have to show that this incident ray and emergent rays are parallel. For the purpose, we will take the help of Snell's law of refraction, and it is related to refractive index. So for interface AB, we will have mu21 is equal to sine theta I upon sine theta R. For interface CD, we have mu12 is equal to sine I upon sine R. These two equations we have taken with the help of Snell's law of refraction. Now if we consider the last result and put it equation number 1, then this equation number 1 will give us sine theta I upon sine theta r is equal to 1 upon sine I upon sine r. If you simplify, we will have sine theta I upon sine theta r is equal to sine r upon sine I. It's very simple. We have taken reciprocal of the right hand side because it is 1 upon. Now if you see from the diagram, these two angles are equal. Theta r is equal to I because these two are normals to the interface AB and CD. So theta r and I are alternate angles. So but angle I is equal to angle theta r. These two are alternate angles. Then sine theta I upon sine theta r is equal to sine r upon sine theta r. Then it will give us sine theta I is equal to sine r, which is possible only and only if theta I is equal to angle r. That is if you see the geometry of diagram, these two angles are angle of incidence and angle of emergence. Now it's very clear, if these two angles are equal, then definitely these two rays, incident ray and emergent ray, are parallel to each other. I hope you understand this concept. That emergent ray is parallel to incident ray, and this is mandatory. Whenever you draw the diagram for refraction for any bounded region, then it is necessary that incident ray and emergent ray should be drawn parallel to each other. Thanks my dear student for watching this video. In the next lecture, lecture number 3, we will discuss about the refraction at the interface. The ray is traveling from denser medium to rarer medium, and that would be quite interesting to learn a few more things. Thank you very much. We will meet in the next lecture. Thank you.